As you can see from the title of the lab, we're doing static and kinetic friction. There are two main experiments. One experiment is really kind of two things going on at once, and then the second experiment is a second way of measuring the kinetic friction. So in the first experiment, we'll measure both the static friction and the kinetic friction, and then in the second experiment, we'll measure the kinetic friction through a different method of data collection. And then we'll make some comparisons. So the equipment we've got for the first experiment that we're doing, this is a force sensor. So we've got our force sensor, and down here in the corner you can see right now when there's nothing attached to it, it should read 0, shouldn't it? But it's not. So we're going to go over here to our experiment 0. Now my sensor is ready to go, and you can see that I thought I had a little weight here. Here it is. If I hang something from my force sensor, okay, there we go. That thing weighs 1.57 newtons. In other words, this thing measures how hard you pull on it. So I have this block on the table. Every block that you will get has two sides to it. We are going to use the wooden side. Use the wooden side. Place the wooden side on the tabletop. And you're going to pull it until it begins to slide. So you hit, you can see right here it's set on 10 seconds. You can go in the experiment and change the amount of time. I found 10 seconds works well. If you need more time, you can change it. Hit collect. And then I'm going to slowly pull, increasing my force until it starts to slide. And then I'm going to pull it at constant velocity. Okay? Now that doesn't look like much, but I'm going to zoom in on it. Auto scale. There we go. Okay, so as I pulled harder and harder, the block was not moving yet. I know if the block is not moving, my pulling force, which I'll call the tension in the string, and the frictional force, little f, they must be the same, because the sum of the forces in the x is equal to mass times acceleration in the x, and if it's not accelerating, the forces must be equal and opposite. So even though the string, this is a measurement of the tension in the string, it's also a measurement of the amount of friction that is present. Okay? So I pulled, and then it started to move. And as we know from paying attention to the lessons, that once it begins to move, the kinetic frictional force drops. And it becomes less than the maximum static frictional force. And that's why I was pulling the block at constant velocity, because that means the acceleration is once again 0, and now the frictional force is equal to the tension, but now it's the kinetic frictional force. And as you can see, the force sensor, it jumps around. So what value do I use for my kinetic frictional force? What you're going to do is you're going to highlight the region of kinetic friction like that, and analyze statistics. And now inside that box there's a value for the mean. Okay? So 0.948 newtons. My maximum static frictional force is up here. Click on that spot and it'll give you the data point right here. So my Fs max would be 1.352 newtons, and my Fk would be 0.95. Okay? And that would be the data you record in your data table, and then you repeat it with 500 grams on top of the block, and then you do it again, I think, with 1,000 grams on top of the block. Okay? And you get a couple data points, and you fill in the data table there. You notice how it says total mass. So you need to know the mass of your block as well. The triple beam balance is in the back of the room. All right, so that's the first experiment. The second experiment, we're going to disconnect now our force sensor, and we're going to use the motion detector. I'm going to take the block and I'm going to slide it towards the motion detector like this. Okay, just like that. And what are the forces acting on the block while it is sliding? The tension force is gone now. As the block has velocity in that direction, I know it's the kinetic frictional force that is causing the block to slow down. Okay? So while I slide the block towards the motion detector, you can see I'm going to get a graph of velocity versus time. Oh, baby. Thank you. Not you, baby. This baby. Yeah. Thank you very much. Okay. Very nice. What do I expect? We've been telling you all along, thank you very much. We've been telling you all along that kinetic force is a constant frictional force regardless of the speed of the object. Okay? Now, what evidence do I have from this graph that proves that statement? Well, the force is related to the acceleration. They are proportional to one another, right? Where do I get information about the acceleration from this graph? The block was not moving, 0. I pushed it. So now I've got some negative velocity, and then it slows down to 0 again. And what do we see about that graph? It is a straight line. What is the slope of that graph? The acceleration. So it is constant. The slope is constant. The acceleration is constant. If the acceleration is constant, the force is constant. And now I take the mass of my block that I measured on the scale, and I multiply by the acceleration, and I come up with the kinetic frictional force. Okay? Now in this part of the experiment, if you look at your data table, it tells you to do it again with the 500 Newton weight attached to it. But if you slide this across the table, this weight is going to fall off. So you will need a piece of tape. Obviously, do not wrap the tape around the bottom of the block, because the bottom of the block is where the friction is occurring, and we don't want to adversely affect that. So you have to tape the weight only to the top surface, just so it doesn't fall off. And as always, be careful of your toes. If one of these weights falls on the floor and lands on your foot, it does not feel good. Okay? Any questions?